Hello and welcome back again. I left you with this question with the previous lecture. What is the purpose of a search engine? We'll talk about that in a moment. I want to note that I have uploaded into Learn it says it's Chapter 9, Information Representation. I actually don't know if it ended up being Chapter 9 or not. Maybe it did. It probably did. This is the final version that I had of a chapter that I wrote for inclusion in a book. And so I have it in this nice format for you for you to read. Please go ahead and read that. We'll be talking about it soon. It's kind of nice. I like it. I wrote it. It gives a background actually in information retrieval before we had computers, heading in a little bit, and then heading into the computing age, and some real fundamental points with regard to how are we going to take all this text information, process it, turn it into something useful that we can use for retrieval. And it talks about a whole bunch of things in there as well. I mean, it's only one chapter out of an entire book, but it's sort of a fundamentals of information retrieval, and my future lectures will be based upon it. All right, so back to the question. I hope you've had a time to think about it. I appreciate the comment in Campus Wire, the post, investigating whether the COVID alert app is a search engine or not. I gave my feedback there. I really like that sort of thing. So please feel free to go to Campus Wire and engage with me, engage with the other students. Would be nice to see other students respond to messages like that as well. So this question is posed in a particular way. Purpose of a search engine. And it's not what is a search engine or what is not a search engine, but what's the purpose of one? Because we need to know its purpose if we're actually going to be involved in the business of engineering one, creating one, improving one. We have to know where our goal really is in this design space. So we could have lots of ideas and things, and I'm sure once we had our discussion, we'd kind of focus in on something that we all largely agree upon. One of the ways I like to have this, I believe I actually picked this up from Professor Vechtamova, who's also in the Management Sciences department, but is this way. So a search engine helps people better satisfy their information needs. All right, and let's look at this and let's talk about this a bit. One thing that jumps out at me here is people, and this is how to put this, but people are really unique, okay? Each one of us is different. We all have different things that we want in this world. Now, sure, there's some basics, we all want some food and some shelter, to feel loved, all sorts of things. But when it comes to the problems that we're facing and the tasks that we need to solve, they might be highly similar, but each of us has our own unique perspective on things. And a lot of this comes about because we have all lived our own lives. Our minds are filled with all sorts of knowledge and experiences that forms the context of how we understand the world. And when we go forth and we need a search engine, and we've got some sort of task we're working on, we could say it at the high level, it's a task. But that task, then we're like, we realize we need some information. We need something to help us complete that task. So we've got this information need. Well, our information needs are often unique to us. Sure, we might have a simple request, which is the elevation of Mount Everest. Okay, and it seems simple. Let's return some answer to you. But you know what? Let's think about even that. Depending upon who the person is who's asking that question of the search engine, who wants to know, their information need is, I need to know the elevation of Mount Everest. They might want an answer in feet, or they might want an answer in meters. I know, having grown up in the United States, that I'm very attuned to things in feet, for example. But gosh darn it, I'll tell you, Google, when it sees that I'm from Canada, it's convinced that I want the metric system for everything. I've tried everything in the world I can do to teach Google. No, usually I actually want certain things in terms of feet, miles. I don't really care about these kilometers and meters and stuff. Sure, some things I want in the metric system, but a lot of my information needs, if I'm asking for a distance or a measure, is different. It's like, what's the temperature right now? I want it actually in Fahrenheit. That's what I was brought up with. That's the language I speak for temperature, that it's convinced it wants to tell me it in Celsius. So who I am, my context, changes what my desired answer is. And all of a sudden, by the way, this really should strike you as a bit of a problem, because the same exact query could come into a search engine, and depending upon who issues the query, their context, who they are, they may want a different response. And it's not just that it's a different query or a different, so it's not like it's an ambiguous query. So it's not like you typed in the word Windows. Did you mean Microsoft Windows? Did you mean the windows in your room? Well, what do you want? I don't know. That's such an ambiguous query. I'm not even talking about that. I'm talking about something that's, like the elevation of Mount Everest is not that ambiguous. But you might want different answers for it. And you could even want different amounts of detail. Someone could actually be beginning their research project on the history of efforts to measure the height of Mount Everest. And that's their initial query. They want lots of information about the elevation of Mount Everest, all the different surveyors. Is Mount Everest rising up out of the earth still, or is it shrinking down? What about the measurement errors? All these sorts of things, as opposed to someone who just wants what we might call a little factoid, a little piece of information. I just want to know the elevation in feet by some fairly reputable source. Probably because, maybe I'm in a conversation with someone and we're like, is Mount Everest at the height that commercial jets fly at, or is it higher, or is it lower? You're at some sort of a bar conversation or something. Oh, quick, get out your phone. Height of Everest. Oh, it's so many meters. Oh, I don't know. All right. So the person will often drive what the correct response is with respect to a query. It's their information needs. And people are highly variable. They come with different reading abilities. We have children. We have, professors. We just got this wide range. And they all could type in the same thing. They could have a time deadline. They need the information really, 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 really fast. Because I got to get the answer now before this, that. They could actually it could be something entirely different. They're like, look, this is a really important information need for me. You know what? If it's going to take you a couple hours to get a good response, I'm fine to wait. And now you can think about that. You're like, who wants to wait hours? Well, there's all sorts of things where you could be very interested in a very high quality set of results coming back. You can envision engaging a human who's actually using all sorts of tools to search over things, to find things using their knowledge, and they're preparing an answer for you. And sure, they might be hidden behind a computerized screen. There's still an information retrieval system, a search engine. It just might take a really long time. There's been all sorts of proposals, by the way, of using sort of human workers to take and work on query a request and come back with it. But it's slower. You pay more even. You're engaging all these people, but it might be worth it to you depending upon what it is that you're looking for. So this notion of better, okay, again, we've got the big issue of people, and they all have a different context. This is what's in their brain, this, all of this basically leads to, each person has their own notion of what are, let's just say, are good search results. And even this, though, is, I'm hand waving. Who says we need search results? Maybe you compile a summarized document automatically for someone. Maybe you provide them with a video summary. Who knows what it could be? So each person, something different for the same request. Sure, it's not truly the same request because the request becomes not just what you type in, not just what you query, but who you are, your context. That's the total request, and it's unique and it's different. But sometimes we get in the habit of thinking about, well, they typed the word weather. Okay, it's just the query weather. Let's answer the query weather. So, or height of Mount Everest or whatever. But it's not just that. It's who the person is, their context, what their search task is. It's not even just a search task. People don't really have search tasks. They have tasks that they use search to help them with. All right. Better. That was my next word to underline, and I got diverted for a second there. Better. Well, I already talked about this. Fast versus slow, etc. I think the thing to really point out with better is it's sort of an economic thing, and it's very complex. But certainly when we mean something is better, it means that this search engine helps you better at that problem that you're facing than another search engine. So if I was to ask the user, is this search engine better or this search engine better? The user will tell me which one is better. I don't know necessarily why, and it might be very difficult for the user to explain and quantify why, but they could tell me this is better. Likewise, when I talk about economic, we're always faced as humans with trying to satisfy these information needs in the midst of our tasks that we're solving in an efficient manner. Take, for example, you have let's say a washing machine at home, and it's starting to make some noise. It doesn't sound right. All right. You're worried about your washing machine breaking. You're worried about that it is broken. You decide to start investigating and figuring out and solving this task that you have at hand, which is my washing machine is making noise. This is concern to me. But think about it. Sure, You can go to a search engine, start typing in, I have this brand and it's making noise, and you could start investigating it. You could also, though, you could call maybe you're still young and you want to rely upon the advice of your parents. Oh, hi mom, hi dad, how's it going? Yeah, my washing machine is making noise. You got any idea what I might do? You might call a friend. You might call a repair person. All sorts of things that you could do. Those are all sort of search engines in disguise, Yeah, you're calling your parents. They're like a really real intelligent system, not an artificially intelligent one, a real intelligent one. Same thing like a repair person. These people might actually be able to help you diagnose things really quickly, satisfy that information need that you have, and they're better than the search engine. So if the search engine isn't better, it's not going to get used. But better is a very complex economic thing, because I can turn to my search engine at any time. It's up and it's running. So it's 2 a.m. I got an issue in the basement or something, water leaking or something's noisy. You can turn to your search engine. Unless it's a real emergency, you're probably not going to be able to reach a repair person. You're probably not going to wake up your parents, so forth and so on. So it's complex to understand what is better and when something is better. We're going to talk a lot about this and how to evaluate stuff. But yes, I think search engines really fall within the notion of there's some information need, and it's an information need. It's largely in service of some task. We could call it a task that you're trying to. Sometimes the task is, I'm trying to find a piece of information. Fine. So it's just truly just a pure sort of search task. But other times it is. It's things like fixing that washing machine, dealing with trying to find and compare and buy a new car. Pick a new neighborhood. Whatever it is, these are tasks that then you utilize information to help you solve. And I would say a lot of what happens are tasks. And even, come on, I want the height of Mount Everest. Well, again, I gave the example that you're in a bar in a conversation. You just need to know it. It's in service of the larger conversation task that you have. Anyways, that's the purpose. You got to remember people, that it changes what the answer is. It's complex to figure out how to define better, and we're always thinking in terms of information needs. So let's not get ourselves confused with just all information systems out there and stuff. It really tends to be that we have a search engine. It's going to be defined over, it has some collection of data. Usually, and in the context of this course, that data is always going to be textual data. That's the key problem that we're solving, is we have a bunch of, let's say, documents. We'll call them documents. And they're written with words. And now we're trying to find the documents or the portion of documents that will be useful to us to help us with satisfy our information need. I'm not concerned about data analytics and, I've got a whole repository of measurements or something. That's not what we're dealing with here. We're dealing with text, we're dealing with language, and we want to deal with finding out of that body of unstructured textual data, the text that's going to help us, the documents that are going to help us satisfy our information need. That's really what the context of our search engines are. All right. Certainly, you can see that Google pushes this to be like a complete, total information system. I mean, it includes things like flight departure times. It includes the latest weather forecast from or something like that. I mean, it includes data that could much better be understood as perhaps being part of structured database, and they blend and they merge it all together because they're running a business and stuff. But for the context of our course and what we think of in general, our search engines are going to be over a set of documents. These documents are written in a language. The only language we'll use in this course is English, and we're trying to find which one of these documents, which set of them would best help us satisfy the person's information need. All right. Okay, so with that in mind, what I'd like to do now is I'd like to talk about some of the large conceptual level of things in information retrieval and in search engines. I promise, get you a syllabus out, and you'll see on the syllabus I've got a little picture here drawn on it. I'm gonna draw it out now here. I hope so. I'm gonna give it a try. The course is called Search Engines. It used to be called Information Retrieval Systems. Students would abbreviate the course IRS, which is weird to me because that's like an Internal Revenue Service in the United States, like the CRA in Canada. Nevertheless, I think Search Engines was a better title. The full title, though, really of the course, the way I see it, is this course is Engineering and Optimization of Search Engines. All right. Now, what does the engineering portion mean? It means that we're going to look at how search engines are built. And what does the optimization component mean? Well, this means we're concerned with better user experience, and as well, this is basically to better satisfy those information needs. What we're going to really start to talk about is this notion of search quality. How good are we at finding the documents that a person wants to find? All right, so engineering and optimization. How do we build it, and how do we study it and make the system better for people to better satisfy their needs? All right, so at the far end here, we start off with, my drawing may not be as good. That is pretty bad. Let me try again. There, this is better. All right, we start with our friendly person here. Okay, I could give him an eye, or her an eye, but let's not. Let's just keep it like keep it sort of nebulous. This person starts off, and again, they have some need. You know, they want some outcome to come about through using the system. All right, and so then they go ahead and they've got some interface to the system. This is like their computer screen. Okay, this thing allows them to supply input to the system and get output. This is an interactive component. They get to interact with it. This interface could be all sorts of things. People have envisioned lots of things over the years. It's not just what we see today for search engines where we put in a query and we get a bunch of links to click on. It could be anything that you could envision it to be, actually. And that's one of the things that's fascinating is what could we really come up with that we haven't thought of already? Why are we still, maybe what we have, maybe we really have come up with sort of the optimal interface for search engines. Sue Dumais, famous researcher at Microsoft Research, she famously said more than a decade ago, like, if in 10 years we still have 10 blue links, I should be fired. We don't just have 10 blue links, so Sue doesn't get fired, but the search engines largely follow the same interface format of query, put it in, and give me a bunch of results that I can click on. that hasn't changed. It's fascinating how much it has stayed that way. Anyway, so user's going to interact with that thing. It's connected into our search engine. And we can think of our search engine as made up of certain components to it. I'll picture them here as gears. It's as if we had some sort of mechanical system that's running and working and interacting with each other. It's just symbolic. Obviously, it's all computerized. We don't have gears inside of it. But yeah, the search engine has to have something in it where it collects documents. All right. It needs to deal with processing the text. We can't just have just text. We need to do something with it, like we do as humans. We as humans, we break it up into words. So we're going to break up the text into words as well. There's components in here that we process it. We build an index for speed. But then we've got our rank. So we get a query in, and we've got a ranking component. We're going to, over all the documents, figure out which documents we want to put at the top of the search results. And sure, the search engine has to deal with the user interface as well. What is it going to show? How is it going to be? And these are all sort of parts that we can change and work on, to end up hopefully with a better system. A lot of work goes into ranking, but ranking, in other words, what's the order of the documents we should show people? But, it depends upon the text processing. It depends on which documents we put into the system. And it all deals also with our user interface and the human who's actually interacting with that system. So that's our search engine there. As a person uses the search engine, by the way, sort of we can envision that comes out of it our usage logs. Okay, and we're recording how people are interacting with it. By the way, modern web search engines record everything. So they record not just the query that comes in, but they record also what they returned back, because again, it's a very complex system and they really need to know what was it that they gave back. They're changing the system actually probably at least once a day, if not multiple times a day. Constant improvements are going in. So they record what they send back. They record where things are on the page and so forth. They're recording where your mouse is. They're recording the amount of time it takes you to decide to click on things. Not just what you click on and when you click on it, but where your mouse is, where you scrolled the page, what's the window that you're looking at. All of this is getting dumped into gigantic fields of data. So when I say usage logs, it's really nowadays, it's a complete recording of your behavior interacting with the search engine. All right. Now, that's great. But how are we going to get about dealing with improving it? How do we make it better? Well, one type of evaluation, and we call this evaluation and information retrieval. How do we evaluate the quality of a search engine? Okay. So one of the steps that we certainly have is sort of in situ or field evaluation. All right. So you can work at Google. There's a group there. And what they do actually is they go out and they actually visit Google search users at their home, at their place of work, and they observe them actually using the Google search engine. And they make observations about how people search. And they bring that information back into the company to inform the other researchers, to inform the developers, because we could have a fundamental misunderstanding about the sort of needs and behavior that people have, that if we don't go observe them and talk to them, that the usage logs just, they're not going to reveal it to us. I still remember in the early days of the internet when I worked at a company, and we were working with an online retailer. I think it was one of these early online retailers of wine. And the users, we were talking to them, and this was over a phone call, and the wine company, the e-commerce company for wine, was describing a customer and her behavior, and they said, oh, and she was trying to do this. And we all just were like, what? Wait a minute. They were like, how did you understand from she put this in her cart, she clicked this, then she did this, and then she did this, and then she did that her goal was whatever that was. I don't remember the exact example, but it was just like, how could you infer that deep knowledge and information from your usage logs? And they go, oh, we didn't. We know who the customer is. They give us their name, their phone number, and their address. We picked up the phone and we called her, and we asked her, oh, we saw you doing this on the website. Could you tell us what you were trying to do? And she told them. And I still remember going, whoa, that's so amazing. You can talk to people. You can ask them, what was your intention? What was your goal? What were you striving to do? What would lead to a better experience for you? If you don't talk to and engage with the real people with an information system, you just try to like, oh, I'm recording the usage of it, you're missing out on potentially some very deep insights. Okay. It's kind of like, oh, I'm a professor of this course, and I'm just going to observe the test scores of students to determine how well the course is working. Can't tell much. Oh, but I can do course evaluations or midterm feedback. I can ask students, tell me something that I should keep doing and something I should stop doing. And they'll write out stuff and they'll say things along the lines of, oh, we would like to, have more time for this, or we'd prefer it if this was to change, or when you do this, it's frustrating and hard for us to understand. Okay, wow. I can't tell that from the measurements I have of their usage. I need to actually talk to them and find out what's going on. So you've got this. This is one way to evaluate a search engine. Another way to evaluate it, no, that's the biggest thing. That's that form. Let's move on to the next one. I already started talking about that, which is the notion of these usage logs. Well, let's envision we've got them going into something, a log processing step here. I kind of like to draw these things as, it's like a grinder, and in come the logs, chunk, 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 and out come what we will term online metrics or online measures of quality. So absolutely, in modern web information retrieval systems like a search engine, you're doing all sorts of stuff like, when someone sends me a query, what fraction of the time do they click on a result? What's sort of the click-through rate, the CTR? And that's an online measure of performance. If my click-through rate is going up, I must be serving things that at least appear to be what people want to click on. But you start to do that and you realize, well, wait a minute. I see people click, and then in about, 12 seconds or so, they hit the back button and they're back to the search results again. And again, remember, you're logging all the interactions with people here. And by the way, when you're using web browsers from companies like Google or you're using them from Microsoft, usually there's fine print somewhere that says, would you like to help us improve your experience using things? And it's not just about the usage of your web browser, it's about your overall usage of the web. So you will end up sending them that, because when they run their search engine, they can see what you click on, but then they can't see you on the next page. But they went to the trouble to build a web browser. Wasn't that nice of them? Well, that web browser, though, knows where you went, and that web browser can tell them where you went, so that they can actually form a deeper understanding. Now, they don't do this for everyone, but certainly there can be a sample of people that they collect very detailed histories of web browsing behavior with. Nevertheless, so we see you hit the back. So if you don't stay long on a page that you clicked on from a search results, maybe it's because you really quickly saw what you wanted and you were done. But why did you go back to the search results then? Oh, maybe because you had something else to query on. But wait a second, what if you go and click another thing? And then you spend a long time on that page. Basically, what we can see and we understand is this phenomenon of the quick back. So you click on something, you go, ooh, that's not what I'm looking for, and you hit back. So you're basically often in those sort of situations, you're dissatisfied with your search result that you clicked on. And in fact, that click then was a negative piece of feedback, okay? You should not count that as success. Imagine it's like clickbait. Ooh, the search result, I want to click on it. And you click on it. Ooh, that's not what I wanted. All right, so those are not, if you just measure click-through rate, you'll be deceived. You could start putting all sorts of garbage up there, and people are clicking on it, but they're not happy. So measuring quality from online usage, and by online, it means the system is running right now. We're keeping these logs, and it's an online measure. We'll talk about offline in a second. It's a science in and of itself. Okay, so let's study people, how they actually use the system. Let's, from our behavioral traces, extract measures of the quality. Now, let's think about some of the differences here between these. This is really slow and expensive. You're taking usually PhDs, they've got anthropology and human-computer interaction and other sorts of training. You're putting them, they're driving out, they're visiting people, they spend a day observing someone, they write a report. That's like one person maybe eats up maybe nearly a week of time, or maybe a couple days of time, okay? This search engine like Google is flying through millions and millions of queries a day. And people are clicking it, like the data that comes in is huge and fast. And all your metrics, these are automatically computed. They're being done. You're writing your algorithm to process these logs. So that's really cheap, so to speak. And it's got huge scope. You get tons of users and tons of data, and it's processed really quickly. But in exchange for that efficiency and breadth, you're losing lack of insight and depth. This person here, click, who knows? Just like that person for the wine site I was talking about, you might, from the usage, have no idea really that they were excited, they were disappointed. So this is a really useful form of interaction, of observation, and it gives us, though, something different than online measures do. Great thing, though, about online measures is, let's say you deploy a change to the search engine, you might really quickly be able to detect a negative impact upon your online measures. And so you could be alerted to, essentially, oops, we actually did something that was bad. We want to revert that. We want to get rid of that, pull it out of the search engine. That was a mistake. All right. So this lets you have online monitoring of what's going on. It's a good information source, and it's really broad. All right. Now, that's our live working system, but we don't just work with our live system. We've got to be engineers, and we've got to get some work done otherwise, so let's draw some smokestacks for our research and development facility that we have here. I guess maybe smokestacks are not appropriate, but it shows that it's a real physical world that we deal with. All right, we're here in our great research building. Maybe we're Microsoft Research, or maybe we're a startup in our garage, whatever it is. And what we're trying to do is we're trying to develop new search engines that are going to be better and work better for people. And so, yeah, we've got Engine A here. Vroom, vroom. Okay, I'll stop with my sound effects. Hey, Engine B. All right, we're going to compare these. And of course, each of them has their little cogs inside of them. The idea being that maybe we change the ranking algorithm in Engine A, or we change it in Engine B, and we're comparing. Maybe Engine A matches what's the real world right now, and Engine B is our new prototype. All right. Now, we have two big ways to try to evaluate these without actually engaging with the actual live usage of the website. We want to come up with new things before we ever try them out with people. This is a real active business. People are depending upon it. We don't want to mess them up unless we're pretty. In other words, we don't want to try new stuff on them unless we're pretty confident it's going to work. So we got to determine over here in an offline fashion. So that's what we're talking about, the online versus offline. We want to offline figure out whether or not something is better or not. And so one way is we can absolutely bring in, I'm not going to draw too complex of faces here, but we could bring in real people. We could conduct a user study. This is a classic human-computer interaction. And we could ask them to use each of the search engines, Engine A and Engine B. We could set up a user study. We could give them particular tasks. You are in a bar with a friend and you're having a discussion about airplanes and elevation and this and that, and can people breathe without masks at certain elevations, and your friend says, well, what about Mount Everest and this and that? People go to there without oxygen, but some need oxygen. Oh, let's find out the elevation of Mount Everest. So you could give the people you bring in for the user study this scenario, this search task, and say, use the search engine to deal with answering this information need that you and your friend have in the bar. Oh, okay. And each of these people uses these search engines. We actually would give them multiple search tasks. So a user would have Engine A with some set of tasks and Engine B with some other set of tasks. We can't really ask them to use the same task on multiple engines because, again, the moment you do a search, it permanently changes your brain. You're like, permanently changes your brain? Yes. You will be exposed to information and you will have interacted with it, that search task, and learned things through the results that come back that could change your behavior if you then try to redo that search task on Engine B. So when we do real humans, we often have to have them do lots of tasks so that we can average out the performance, the quality, how much they actually like, how satisfied they are, how quickly they're able to find answers, all sorts of measures that we can have. We can talk to them as well. They're in their real user study, how satisfied they are, and try to decide what's better with Engine A versus Engine B. The problem, so you can do user studies. The problem with these is they're a little similar to dealing with this field observation. We got to get the real people into the laboratory. We have to work with people. They can only do so much per given time. Sure, we can do more of this with people than in the field evaluations, because they come to us and we put them in a laboratory setting and it can be more efficient. But it's still nothing compared. It's still really slow. what we would actually say is quite expensive. It takes us lots of time, and time is valuable. We're going to have in these engines, we're going to have these ranking algorithms, okay? And these ranking algorithms can have a large number of parameters to them. Would we try to tune the parameter settings to optimize the parameters of a ranking algorithm by having people do things with a user study when we've got potentially thousands of different combinations of parameter settings? No, absolutely not. That would be way too inefficient and too expensive. Our rate of progress would be glacial. And so wait a second. We can't just deploy stuff to the world constantly, because we could affect people and we might not, so that's not a good idea. This is too slow. That's too slow. What's our solution? The great thing is we can have the idea basically of simulated humans. This is, we got our 3 sort of robotic users. Obviously, they're just truly computer programs. They're not really robots. And we can simulate the notion that a user issues a certain query in trying to satisfy their information need, run it against the engines, all right, and then simulate and measure what we think the quality as perceived by the humans would actually be. And this sort of evaluation that we have here, we do by forming what we call test collections, all right, and having with them effectiveness measures. And the idea behind a test collection is that a test collection consists of a set of documents. We're going to give you a set of documents to work with in this class. So you're going to get a set of documents, and we decide what they are. So if you're a web search engine company, you have a set of web pages that you've crawled. Maybe you've got 1 billion web pages that you crawled, and you're going to use those documents. And by the way, you're going to keep that collection static. You're not going to change it every day. Whereas your real web live search engine, actually the collection, you're constantly going and fetching new web pages and feeding the new web pages in there. Why would we keep it static? Well, we need to be able to compare results over time. Sure, every so often we'll update our static collection, but we don't want, we ran an experiment in the morning to be different than the experiment we ran in the afternoon, simply because we changed the underlying collection, the collection of documents we have. So we're going to have a collection of documents. Part of that collection of documents, though, is also going to consist of what we will call search topics. These are descriptions, again, of what that information need is, what the user is looking for. And in particular, this will be the query that is issued to the search engine. So, elevation of Mount Everest is the query. All right. And then, okay, great. We've got documents and queries, but how do we know whether we ever got the right answers? Or did we get good ones or bad ones? Well, in building a test collection, one of the things that we also need to do, though, is we need to try to find, in advance of running our experiments with our simulated humans, we need to actually build our knowledge and basically know what are the good documents. What are the ones that the user would find useful? What ones would better satisfy their information need than other ones? One of the terms that people use is how relevant is the document to the user. And that, by the way, it's relevant to the user. It's not relevant or not relevant. It's again, the context of the person and would that person consider it relevant. So what companies do and what researchers do as well is we hire people in advance and we work to build out for the set of documents for our search topics. Also, what is the set of documents that are known to be useful? What are the set of documents that we would consider relevant for the user conducting this search task? And so with those relevance judgments in hand, then we have a complete test collection. We've got documents, queries or search topics, and what are the relevant documents. Now we can run the query against the collection that's indexed and has a ranking algorithm in engine A versus engine B. We'll get different rankings, and we can then see where did we put those good documents. Are they near the top? That's better. Ooh, are they near the bottom of the ranking? That's bad. That's the essence of that's a simplified notion of what these effectiveness measures are. It's how can we estimate from this offline usage, this offline experiment, what the quality of a search engine is. Our goal is to be able to work offline and to be able to make a prediction of what would be happening with these people, but not just with the real people here in a user study, but also we ultimately want to be able to go all the way from here to be making a useful prediction that a change in a search engine actually is going to affect the people here in a positive manner. All right. Now, that's a long reach to be able to find and get that correct, to be able to make a prediction like that. But I do have to say, that is how we've gotten here today. This is the history of what information retrieval has done. Because it is an empirical field where people actually measure quality and are constantly working against these measures and their test collections and working in this fashion, we have been able to see these huge strides in performance improvements. It's not a haphazard thing. It's not sitting there and going, I think this looks better, or I think that looks better. It really is. We're constantly trying to measure it, and we're obtaining multiple measurements. We've got our offline with our offline test collection. We're doing user studies offline. We're monitoring usage, and we're checking things out with people in the field. What's the normal path and progression for something going from this end? Well, yeah, so I came up with a new algorithm. My simulated humans or my offline test collection and its effectiveness measures says it's 2% better at a statistically significant level. Okay, good. Then you are likely to actually have humans look at those. You might not do a user study with them, but you at least might have humans look at the search results side by side and say, do you like these better than these? Get a human feedback about whether or not the search results actually look better. Oh, it passes the side-by-side test as well. Okay, great. Now that it's passed the side-by-side test, because we've got millions of users, what we're going to do is we're going to take a tiny small slice of them, a little teeny fraction of them. And for them, when they come to the search engine, that tiny little fraction of people, we're actually going to have them use the new algorithm rather than the old algorithm. And we're going to monitor their online behavior versus a control group who's still using the old algorithm for ranking. And we're going to see what changes we see in the online measures. If across all of our online measures, we actually see a positive improvement of things, that's good evidence that it's probably a good thing to do. So then, if it passes that stage, then we can roll it out to the whole set of people online, and we can be monitoring that and make sure we didn't really miss anything. And of course, long term, people are going to be checking in with people in the field, seeing how things are going. But the field measurements aren't going to be used for a little change to the ranking algorithm or a little thing here. These are to be able to capture long-term trends and issues that are happening with the design and optimization of our search engine. This is what engineering and optimization of search engines is. In our course, we're not going to have user studies. We're not going to have online usage logs. We're not going to have in-field evaluation. We need to be able to work in an offline fashion in an efficient, affordable manner. And so we will be working, our evaluation is with traditional test collections, where we actually know what we believe to be the correct answers are. And so we've been working at this far end of the thing, but that's the overall picture about what's actually happening in industry. And so what we do learn in this course is the starting point and is the fundamental basis of all the work to deploy and determine whether a search engine is actually successful and to continue to work and improve it. All right.